Good afternoon to all of you and welcome Mr. Sachin Rele to this next webinar series. This is a part of the Azadi ka Amrit Mahotsav. This is being celebrated as a part of the, we are commemorating 75 years of independence and glorious history of people, culture, and our achievements. This is also dedicated to people who have made a significant contribution to the country's evolution up to this point, and to those who are actively working to India Vision 2. This is a government initiated program that will last for 75 weeks and will inculcate a sense of love, respect, and pride towards our country and its rich tradition and culture. It is a global movement where everyone is participating. And we in Skill Council are celebrating this Azadi ka Amrit Mahotsav by organizing 75 webinars. We have already completed 70. This is the 71st on various sectors in renewable energy, waste, sustainable management. And you can say sky is the limit, because environment is a subject where we are covering every aspect, whether it is zero emission goals, or it is for carbon footprinting, or it is for solar, or it is for waste. So we have covered all areas, and we have invited and interacted with eminent speakers who have had very good experience in these areas, and we have learned a lot. So I feel this is a platform where Skill Council is also gaining, and the participants who interact on this platform, they are also gaining a lot. So once again, I welcome you. Today, the topic is solar energy, a part of solar energy. It is a very broad word I'm using for solar energy, but this does not require any introduction. I need not introduce this subject, that solar energy. What is solar energy? We are very lucky to have more than 300 sunny days. So we can use this energy extensively for various meeting our various energy needs, whether it is electrical, heating, cooling. So we are a part, we have been the leaders in setting up the ISA, International Solar Alliance, where we have more than 122 countries as members. And we in Skill Council also have aligned and carried out so many courses in different languages. In fact, I think we've connected with more than 72 countries for training in solar energy. So this is there. We are moving from every year, we are adding megawatts, and moving towards gigawatts. But there is an area in this innovation, new designs, more opportunities in processes, and of course in technology. And this is one area which we are going to explore and learn about today. The floating design is something which is current, and it is being set up. Such plants are being set up all over the world. And I think in India also, we have set up so many plants, and Dr. Rele will really tell us how we are moving forward in this direction and how the designs are there. In fact, I am also looking forward to learn more about this aspect. Conventional PV plants, we know how they are set up, where they are set up, ground mounted, roof mounted. But this is an area which I'm also looking forward to learning from you. So I welcome you, Mr. Rele, to this webinar series. And I would request Mr. PV Singh to kindly introduce you, and then we can have to think. Welcome once again. Thank you very much.
Thank you, ma'am, for welcoming the speaker and other participants. Thank you very much. Good afternoon, everyone. I'll welcome you all to the 71st series of the webinar. Skill Council for Green Jobs, SCGJ, is organizing a series of webinars to celebrate Azadi ka Amrit Mahotsav as part of India's celebration of 75 years of independence. In this series, SCGJ is inviting eminent and learned speakers in different sectors on sustainable development, renewable energy, and waste management, so as to deepen the understanding of recent development in these sectors. The first in the series was launched on 24th September 2021. Today we have Mr. Sachin Rele, a very experienced, learned, distinguished speaker who will be sharing his expertise and experience on floating solar design engineering and opportunities. I would like to share his brief profile with all of you. Mr. Sachin Rele is the Managing Director of Autonic Energy System Private Limited. He completed BSc in Physics, LLB in Commercial Laws from Mumbai University, and MBA Marketing from NMIMS University. He was also the visiting faculty with NMIMS, India's top 10 B school, for over 13 years. He is currently pursuing a PhD program with University of Mumbai. Mr. Rele has proven track record of promoting and operating companies with a good mix of business and technology for 26 years with a total experience of 34 years. He also has a track record of attracting, developing, and retaining talent in the solar PV industry and enjoy high credibility amongst customers, partners, and employees. Handling Autonomic Energy System Private Limited, Mr. Rele has experience with batteries, power, electronics since 1989. Autonic also started a solar division in 2005, focused on solar EPC since 2011, and has completed over 250 solar installations. He has also developed innovative solutions for solar powered applications like India's first solar solutions for ATM, solution for cold storage, freezers, designed wind solar microgrid experience, solar bottle technology demonstration, Sungana solar calculator, solution in renewable energy and floating technology, etc. Now I'm requesting Mr. Sachin Rele to start the presentation. Over to you, sir.
Thank you. First of all, I want to thank you, Singh sir, and the complete Green Council or Skilled Council for Green Jobs for coming up with an innovative and collaborative approach to understand and work with experienced people and work in such a way that we get exposure to a lot of things. And this is a great forum to actually work with people like you. And I encourage all the participants to ask questions. And the part of the learning is also questions. So if at all you are able to ask questions, I'm happy to look at and answer your questions. I'm going to keep a little more time for the questions because most of the part of the solar energy has or floating solar, the technology remains the same. The concept and the application is different. So with this, I will start my presentation. The first thing that I want to share with you is what is floating solar? So this is some question that most of us would ask. What is a floating solar? Floating solar is a comprehensive technology. Before we go into the floating solar concept, if those who have a paper and pen, I just want you to just put it up in a perspective so you'll understand what we are talking of and what is the level of floating solar opportunities that you have. First is the floating solar that I'm speaking of is on water bodies. And when we talk about water bodies, we are talking about freshwater bodies. And as per a TERI report, India has over 18,000 square kilometers of water bodies, freshwater bodies associated with various municipal corporations, irrigation dams, hydroelectric power plants, and various other water reservoirs, which is size of more than 2 kilometers. That is the scope. And when we look at 18,000 square kilometers of water bodies, if at all we are able to convert 5% of that water bodies, or maybe a little more, let's say for the sake of discussion, we are able to convert 10% of those water bodies, into solar, into floating solar projects, we have an opportunity to create 288 gigawatt of water bodies or floating or electricity through only floating solar initiatives. Now, when I talk about 280 gigawatt, I want you to put it up in perspective. What does this 288 gigawatt mean? So let us say if we have to do 100 or a 60 gigawatt project. For a 60 gigawatt project, typically we need 4 acres of land. So for maybe a 60 gigawatt project, we would need approximately, for the sake of discussion, we would need something like 240,000 to 3 lakh square feet of land mass. And if you convert this into square kilometers, it is approximately 1400 square kilometers is the land required only to power or use it for solar. So when I put it up into this, just to give you an idea, this, can anybody know what is the size of Singapore as a country? Singapore as a country is only 720 or 725 square kilometers. So we are talking of 1.5 times of area of Singapore, which is covered only to generate power, which we can generate using our conventional floating solar solution. So this is the landscape that I want to share with all of you before I come and discuss the project. Any questions on this? I mean, you can just put up in the chat box and we will address these questions as and when the time arises. So coming back to is that opportunity size that we are talking about is a 288 gigawatt, of which India has not even crossed. Maybe 600-700 megawatt of power is through solar, floating solar is done. And I'm very happy to say that solar project, as per yesterday's news, we have 68 gigawatt of solar installation in India to be done. And the total renewable energy target for India is about 500 gigawatts. So we are actually on the midway series, and half the installation is done. Half the installation is to be done in next 8 years. So you can imagine the kind of opportunities that are across in for the next 8 years in the renewable energy department itself. So I come across, now we talk about 3 basic things. The first point that I want to share with you is, those who are into solar industry will appreciate this point, is the job of a floating solar is not to supply floats. The most important point in the floating solar ecosystem is to create a complete environment around the floating solar, which means we have to create a sustainable design. We have to look at the layout, and the next most important part is about the planning. How do you plan to look at the system? So in my presentation today, I'm going to share you the contours of how the solar projects will operate, how the solar projects are going to be, floating solar projects are going to be there. Where is the water body? How is the water body managed? What do you understand? What is the potential mapping and transmission and power lines and other electrical items? Before I start, sir, I would want to ask you, Hindi comfortable hai ya English mein baat karu? What is comfortable to all the group?
Sir, you can go with English, no problem, sir.
All right, all right. So ये आपको काम होना है. So the next part that I want to share with you is पहले study of the water bodies देखना चाहिए. Just because there is a water body, उसका ये मतलब नहीं है कि हम लोग उस पर floating solar डाल सकें. So we have to understand what the water bodies is. The next slide is how the water bodies will be. Okay. So criteria for selection of water body is the distance bit from the transmission line. So if imagine there is a scenario, there is a water body which is available, but the distance of this is, let's say, more than 10 kilometers, then we are not sure whether the transmission line can do it. The second point is water level variation. Most of the water bodies in India have a different water level variation which is available. So these water level variations can actually affect the performance of the system. Second is the depth of water bodies. There are some water bodies which are as deep as 200 meters. So if at all 200 meters ka water bodies need to be looked at, we need to identify which part of the water body we need to look at. The next part is the wind speed. Now, those in the solar industry will appreciate that all the wind masts which are put in they are put in at 10 meters distance. But when you look at a wind mast which is at a lower distance, let's say water body is at ground level. So what is the wind velocity based on the lower level has to be looked at. And the last is how is the water hydrography and bathymetry. What are the bottom line areas of the hydrography and the bathymetry which is to be done. Second, before we understand the whole thing, we need to understand what is the type of water which is available, whether it is salt, sweet, waste, or a treated water, whether the water body has a natural soil bed or a man-made lining. Based on these data, the whole system needs to be designed and made for the project. So there is a very rare chance of we choreographing anything which is not specific to. We need to look at, so if the water is salty, then the buoyancy will be different. If the water body is potable, then the kind of technology for the floats have to be looked at. If it is a waste water body, then obviously what kind of waste which is there to be treated has to be looked at. Then there are other important things like how the environment factors are working around it. What is the wind level? So if there is a lot of wind around the area, then the kind of anchoring mooring will be different. If is there any corrosive environment which is around, what kind of bird droppings are there? So if it's very close to a bird park, then obviously there will be a bird dropping around it. What are the algae contents in the water body? Because algae are very important for the ecosystem of the water bodies, and which needs to be looked at. The next part and the most important part for a floating solar is how do we do anchoring of the system? Because what happens is whenever the water level variation happens, the cabling and the electrical system also has to keep on varying. So based on that, there is a chance that if the water level variation goes different, then there is a chance of electrical cabling not being able to support it, which is an important point when we discuss anchoring and mooring of the system. Secondly, if the anchoring is not done properly and if the wind is high, there is a chance that the floats would actually turtle, and or if the water level keeps on varying, then there is a chance of the whole plant getting sucked or stripped of all the installations. So these are some things that needs to be looked at. Primary assessment of water bodies. Then when we do about hydrography and water thing. So imagine career. Now let's put it up in a different perspective. Most of, like I mentioned earlier, we need about 4 acres of land per megawatt. It could be 3.5, it could be 4 acres per megawatt. But when you look at water bodies, we can actually do a 1 megawatt in 2 acres of land. Now, if you have a water body which is, let's say, 10 or maybe 10 square kilometers, we are only looking at 500-700 square meters of land for appreciating how where the floating solar will be installed. So for that, there are various ways of assessing. These multi-beam and single beam surveys are basically sonars to find out what is the water depth, how is the sedimentation, or what are the obstructions which are there onto on the side. And the next important part of this is the side scans survey. So for example, let's say if there is a floating water body and at the edge of it there are sharp surfaces, then when the water level varies or increases, comes ups or down, there is a chance that the side can actually scrape the water body. Then the most important is sub-bottom profile. What are there stones? What are the sedimentations of based on that, the anchoring mooring needs to be decided. What are the tides, whether there are any chances of any, let's say, branches or anything that is coming up on the system that could damage the thing. So if that is to be done, then we need to have wave breakers or tide breakers or protections which are around it. And water level variation is the most important part when you look at it, because depending upon the water level variation, the anchoring and mooring needs to be looked at. So if we have actually designed, or we are working with a project where the water level variation is as high as 50 meters. So how the system can operate with 50-meter water level variation is something that needs to be appreciated. So coming back to my first point is, after you factor all these points of the type of water bodies or the ecosystem of the water bodies, then we define the design and the floats. So solar floating systems is not only supply of floats, it is the whole supply of the complete ecosystem. Now I want to put up to this particular point. This may sound very, very simple, but the tilt of the floats are also going to be important. So imagine a scenario where the tilt is only 5%. Now, for the sake of getting improved power generation, some float manufacturers can come up with a 12-degree. So when you look at the 12 degrees, the difference between 5 degree to 12 degrees is only 140%. But when you look at the pressure coefficient changes from 0.48 at 5 degrees to 2.10 at 12 degrees. So it's a 440% increase in the pressure coefficient, which could affect the complete power plant. The power plant also can be designed at 180 kilometers per hour, but the basic wind speed can be 125 kilometers per hour after extrapolating the capacity of wind speed, because this 180 kilometers per hour, the wind speed is a 10-meter mast. So basically, if at all we are putting up at 0-meter mast, then the wind speed could be recalibrated to 125 kilometers per hour. So these are the additional information that we need to look at, how we can optimize the distance, because more, see, the stronger system or the heavier anchoring mooring that I put in has a direct commercial impact on the price. And what we need to do is, there is a direct mix between the solar project optimization and the power generation and the safety, because these are the three prime pillars of the whole working. Now, this is a rheology analysis of easy floating as a technology, which I just want to share. When you look at the stresses on the wind calculation based on finite element analysis or method, is that the pressures are in 10 kilonewtons here, and it keeps on changing based on. So this needs to be reinforced. So every float that is manufactured needs to be designed based on how the floats have to be placed, what are the stress points that are there, and these are the points, if you, those who are appreciating it, these are the points which are the connection points of the floats. These are connected, these are interconnected. So we need to look at how these interconnection points and what are the stress levels that can come in, and is the system designed to carry this kind of stress. And as a very typical engineering model which we can design is that if it is not able to design or take the additional stress, how do we mitigate the stress points and increase the stress points? That's where the anchoring lines come in the picture. So this is how a typical inverter placement comes in. So there are generally it is recommended to go in with string inverters because they are very convenient and they don't take more space. And this is how you actually connect it. These are the cable trays, and this is where the system gets connected. Now there are a couple of interesting points that needs to be looked at when you talk about. Now this discussion is going to be multidisciplinary. So I'm going to touch on hydrography, which is water. I'm going to touch on the electrical part. We are going to touch on how the design part goes in. We are going to touch on how the ecosystem and the environmental impacts come in. So those who are appreciating the solar project, this is a typical float where all the sides are covered, and this is another model where only the center is covered with the floats, and these 2 points are kept empty. When these 2 points are kept empty, when you look at this, when you have a heat scanning system or heat scanning assessment, then the center is at 44 degrees and the edges are at 40. But when you have a complete closed solar modules, the whole thing is at 40 and 41 degrees. So the average temperature goes to 40.6. In this case, the average temperature goes 42.4. And when we all know that the temperature is directly connected with the performance of the system. So if at all you look at the silicon technology, the most of the silicon technology is that for every 1 degree of temperature increase, 0.4% of the performance gets reduced. So that's the importance of how the system gets affected and how the performance improves. So this is on the super specialization side. When you go on to a non-super specialization side, when you look at it, the temperature here is maximum at 42.4 degrees. Now, because it is 42.4, the performance of the system enhances and the generation is higher than the normal case. So this is something that that happens, and that is the reason why there is a research done by Series, which is a Singapore-based, what is it called? Singapore-based company, which has done assessment of floating solar projects. They have assessed that based on a location and site, floating solar power generation can be anywhere between 10 to 15% higher than the ground-mounted installations. So this is something that needs to be looked at, how the system needs to be adapted. Now, if you look at it, this is a man-made water body. Now, there are chances, and in the current scenario where none of us are aware of the climate pattern. So there will be instances where there will be high rains, there will be instances where there will be drought, wherein there will be no water available. So based on that, the floats also needs to be designed. So if you look at this particular technology, which is done by Easy Floating, this technology can support zero ground water level at any point of time. So if you look at this mark was, there was water around. So look at the anchoring and mooring lines. These are the marks. So these anchoring and mooring lines get reduced. And when the water line actually starts increasing, this automatically needs to be adjusted so that the water can be supported. The typical challenges that we find in floating solar is that heights greater than 1.5 meters need to be, wave heights greater than 1.5 meters need to be relooked at. And how we are able to manage the wave and or using of the wave breakers is something that is a very important point, which is very specific to the designing of the floating solar plant. So this is what we are looking at, a 360-degree approach for people in the OEM. So now when you look at this particular plant, there are two people standing on one float. And if you look at the whole operations, these two people, there is no major variation in these kind of floats, because the buoyancy of the floats is designed in such a way that these two people, which are approximately 160 kgs, this weight is not affecting the solar power plant. So whenever the system has to be designed, the location on which the people are going to do the operation and maintenance need to be reinforced to ensure that the weight cannot carry micro cracks into the solar power plant. So in this case, the system buoyancy is designed at 240 kgs per solar panel. Because this is a bifloat design, it can actually absorb the buoyancy, and it can absorb the two people standing on the same floats at the same time. And this is very important. Now I want to take you to one more point of designing of the floats. The floats usually that we are talking of are HDPE, but they are designed in such a way that HDPE, when you look at it, has a particular concern wherein we have UV rays, and it's like HDPE is the crudest version of HDPE that I can share is a chair, the plastic chair that we have. It's typical type of an HDPE. When you look at the HDPE chair here, after a few years of sitting in the chair, we realize that the chair starts getting fragile, or it starts breaking up or cracking up. So these floats have to have an operating life of approximately 25 years. So the material of these floats have to be designed in such a way that the wear and tear of the floats after 25 years has to be stable. So whenever you are looking at material management as a concept for the floating solar, this is a different subject by itself. But I want to touch upon this because it's about creating jobs. When you look at this, the point wherein the people are standing, we have to ensure that there are no microplastics getting into the water. Because if microplastic starts getting into the water, we will be contaminating the water with microplastics. And this is one exercise that we don't want to add on to. So how the material sciences can be used, what kind of binding agents can be used, what kind of UV protections can be used, what are the standards for the floats and HDP that has to be used to ensure that the floats do not start degenerating. Because if the floats start becoming brittle, then there's a chance that the anchoring point, which you can see here, will start snapping off, resulting into the failure of the system, is something which is not recommended at any point of time. So this is one point that I would request or suggest my friends to give me questions, and I'm happy to address them. Now, coming back to the next point, after understanding all these concepts, the next point is how do you do the layout and what are the kind of module placement that we can do. So basically, we've understood based on the reservoir geometry, we need to place the layout. We need to first understand what is the water level variation into it. Second, we need to understand the presence of what waterworks, whether there are any water intake pipes, whether there are any spillways, what is the total power generation which is required, what are the walkways, how the cables have to be done, what are the evacuation that is happening, where are the inverters to be placed. Based on this design, we can actually start designing the system so that AMC's layouts, reservoir geometry can be looked at. Now, this is the application part of the design that I'm going to talk to you about. So this is a typical lake that we talk about. This is the lake that has been identified. Now, if you look at it, this is a man-made lake. This is very much close to Mumbai. And this is a man-made lake because you can see the lining here. Based on this lining, we've decided that this is going to be a 500 kilowatt project. And this is a place where people will actually walk in. So there'll be a walkway from this point and people will walk in from here for serviceability and operate the systems based on how the layouts and how the desired capacity will be. So in this case, the anchoring, because this is land, because this is man-made lake, anchoring could be at the boundary side here. So this is how the layout will be. This is another layout of the same project. And this is where we have created a subsector within the system. And this subsector could be designed based on the requirements that we have. So like I mentioned, because this is a man-made lake, everything here is anchored or at the periphery. The next part is that, yes, you have seen this plant. How do you actually put them into the water? A good design does not need high-end material moving equipment. So we use the water as our source for transferring it. So when you look at this particular location, what is happening is the complete assembly of the floats is happening on the ground. After it is assembled in the ground, there is this, we call it as a landing pad or the launch pad. The launch pad, it is assembled here and it is slided in the water bodies regularly, so that there is no additional cranes required for mobilization of the system. So now coming back to is three different points that we need to look at how we design the floating solar solution. First is the technical design. Now, when you look at the technical design, is optimization of the floats based on the area, based on the water surface, based on the PV required, based on the anchoring required. If this water body has flora and fauna like fish and plants, wherever there is a minimal impact with the minimal distance is something that the placement of the design has to be worked around it. So as a designer, I would actually place it on the point where there is it's the closest to the evacuation point. B, it is creating the minimum impact for the fishes, minimum impact for the plants which are there on the bottom. and minimum impact to understand where, if there are any, if there is any water level variations, the project should not get damaged because of the variation of water. Then coming back to the product supply, the floats for the PV has to be done with a right plastic grating for the walkways. So we create a great floats, but the walkways are not designed well, then the serviceability of the system cannot be done. Connection of the floats will have to be done with with proper plastic or HDPE and screws which are properly designed for that. PV panel fixing has to be clip-on or screws, and anchoring mooring systems. This anchoring mooring is a complete subject by itself. It could be an ME level subject for anchoring on mooring, because the water body, water strata, technical assessment, geo or water bodies assessment is something that we need to look at. And for the beginners, we can have an offsite training course for how to do the installation. We can have an on-site training course, how to look at it. And there's a technical assistance opportunity wherein we actually look at how the quality comes in. So can we use a drone? Can we use to understand how the fragile some floats will be? The kind of production of the floats are also going to be important, whether they are injection molded, whether they are blow molding, whether they are rotor molding is something that needs to be looked at. And what are the parameters, how you keep on assessing the floats is also going to be important. Okay, now I'm just going to touch on what anchoring is and how the anchoring is going to be used. The first is that precision in anchoring is very important. Length of the mooring lines with proper tagging of every lines is important. So when you look at this particular location, these are anchoring lines which can get intertwined if the system is not designed well. So these are one thing. So if you look at one line that is coming in, it is connecting to multiple floats. If those who are able to see it, they are connected to multiple floats. If there are any questions on this particular point, I'm happy to address them. I mean, my number and everything will be available. You can happy to connect me to so that I can explain to you in more details. So once you look at the anchoring and mooring lines, the final position of anchoring has to be done based on how deep the reservoir is. So A is that you can actually, like I said, we can do it anchoring on the sides. We can do it anchoring in the soil. Now, based on the strata, which is based on the hydrography and a bathymetric study, the strata is something which is going to be important. So if there is any clay or loose soil, there is a chance that we need to have a wedge-shaped anchoring, or then otherwise we can have a dead block anchoring. So that, and while you are doing it, we need to actually keep on tweaking the design based on how we have to do it. Finally, we need to understand what is the maximum tension that the mooring lines can take, and what is the coefficient of correlation between the mooring lines, the water levels, and the anchoring position is something that needs to be established for creating a correct anchoring sort of a solution. Now, these are a couple of anchoring answers that or solutions that I'm putting off. This is an anchor. When you look at, like I said, 1W, this W is connected to multiple different type of anchors. Because the anchoring is different, the stress level of this gets reduced. As a result, the system gets more robust. This is how an external typical anchoring happens. And this is how the anchoring happens at a different level. These are some concepts of layouts for ongoing project into the systems. How the placement has happened. Each placement can happen blockwise, because so we just did a design for a project in Omkareshwar, which was a 300 megawatt plant. So it was done in about 7 to 8 different locations, and each block was 5 megawatt to 10 megawatt based on how the anchoring position will be. So based on that, the whole system needs to be designed. This is a typical another concept which is done, how the anchoring and mooring could happen. This is very close to the water body. these are some of the safety instructions that what we need. We definitely need insulation boots. We need life jackets, ropes, and rafters. Interestingly, we still do not have standards for manufacturing the floats and the floats, because the plant is very much evolving, and because the whole technology is evolving, we have still. So DNVB in Europe is working out for creating standards and national codes for the electrical installations, health and safety, because everything is in water. And one more point I want to discuss and for you is that whenever we are installing these systems, we have to ensure that there is minimal intervention of divers into the system, because we don't need divers to be there, because the whole project cost will increase drastically. So the drivers needs to be looked at, divers which needs to be looked at how and what we can manage. This is where I conclude. I have tried to cover up as many points as possible, and I have been given 40 minutes to talk. So now I would want a good 10-15 minutes of discussions.
Yeah.
So open
Thank
to
you
you.
very much. Thank you very much. It was a very elaborative and illustrative point, this thing. You covered up all the aspects. We'll take some of the questions and then we will have some more discussion with you. I also have 1 or 2 questions. I think Dr. Saxena will also join us, being from the sector.
Sure.
So I think there's a question from Neha Saka. She's saying that she is studying this since 2017, floating PV plants. So she says that what is your opinion about dual-sided PV panels? How will efficiency be affected? And because she feels that water reflects more light than land.
That's a very good question. Now let me ask you differently. When you do it, we try to put the solar panels in minimum space. So whenever you want a reflective surface that is coming up, there's always a chance that we need to spread our solar modules. So when we spread our solar modules, the reflection is there. In this case, there is no reflection because everything is very close to each other. So bifacial modules are not recommended for floating, but the technology, what Neha rightly says, is that there is an opportunity to look at it, but it cannot be a practice. It can be one-off cases. For utility scale, it is definitely no, because more amount of modules that I can put in a particular area, it is better for us. Neha, have I addressed your question?
Yeah. Neha, are you happy with the answer? Yeah. I hope.
Yeah, I think you have been given the right to speak. You can ask more questions.
Yeah.
If you like.
Yes.
Okay, can I ask directly? That would be more.
We can't hear you, Neha.
Can I speak directly? That can be more quick. Am I audible?
Yes.
Loud and clear.
Okay, thank you very much, sir. Your session was really wonderful. And I have been studying about FSPV since my bachelor's degree. I wanted to ask a couple of questions that, as you mentioned, that bifacial solar panels are not efficient when we are using floats. But when we talk about China, they are using the FRP technology, and FRP pipes is what basically they are using. And Japan also has done that. Apart from Hydrelio and Cell Terre, many of them are using the pipe technology only. So in that case, they have a good amount of area that reflects light back to the surface of the PV panel at the back side. So will that be efficient or will that not be efficient? Because I've read some research paper, half of them says that it is and half of them say that it is not. So that is a big question for me. So what is your opinion?
Like I said, there is fortunately, there is no specific answer, yes and no. It is going to be site specific. See, if at all the plant is spread over a longer area, then bifacial panels would add value. So you also have to appreciate that some part of the bifacial panels get covered because of the floats.
Yes, that is a fact.
So because of that float, some area will not be affected. And as you all know, all cells are equally charged, and bifacial panels, even if you have it, so if some areas there is a black dark spot in this case, may affect the performance of the system. So when you look at it holistically, if you really ask my personal opinion, I would not go in with bifacial. I would go in with reduced area, because between you and me, we know that bifacial panels have anywhere between 5% to 15% of additional power, which is anyway generated because of the floats. So I would not go in with bifacial panels in my projects. That's where I would ask.
Okay, thank you, sir. And then another question is that we have seen two technologies that are going good in terms of floats. One is the HDPE floats that you have mentioned, and the first one was to created by the created by CLA Terre. Hydrelio was the first successful float, and then came the technology of FRP that was in China. So is India having its own anything unique technology in this case, or we are just going with the floats only?
See, if you really ask me, today is the floating solar industry has not begun.
Exactly.
Because what is happening is people are doing what we call it jugaad and trying to do it. I'm not talking about CLTerry and other companies, but most of them are doing it based on whatever it is. Now we need to understand what is the UV radiation and the impact of the UV radiation on HDPE over an 8,000 hours. So every location has a different UV radiation. So what is the impact of the UV radiation after 20 years is something that needs to be addressed. And in Europe, there is an 8,000 hour UV radiation test which is available. And if that test is taken, then we'll be able to, in a better position to understand how the impact will be. Otherwise, we are going to cause a disaster when we start installing floating solar without assessing the technology. This is my suggestion.
Okay. The last question that I need to ask, sir, is that floating solar in India has been there since 2015. In Kolkata, they started a small plant and it has been there. And it has been already approximately 10 years, 2 years less. It has already been 10 years. The policies of the government and the electricity department has never issued anything in particular related to floating solar. They have issued their different policies of different renewable energy department of corresponding states regarding rooftop solar or solar parks, but there is nothing in particular with regards to floating solar. So what is your take up on that?
Yes, DNVB is working on standards for floats and floating solar technologies and policies. What happens in floating solar is that two different departments which are there. Water body is a different department and the electricity becomes different department. So how is it going to be impacting the ecology and environment and power generation are two different aspects. So it has to go, like I said, it's going to be a multidisciplinary study wherein we have to actually understand how these two are going to combine together and the policies have to be made. And secondly, is we still learning from most of the projects. Maybe after 1 gigawatt is installed, we will have a sufficient learning to come India-specific tropicalized solution for floating solar. This is my assessment of your question. But I'm sure we are working on how we can optimize the solar power plant and how floating solar power plant is something that should.
But, yeah, because some of the places we have rivers and other places we have mountains. So if you are installing solar panel in between mountains, we would require a longer anchoring system and longer ropes and mooring arrangement and everything. Whereas where we have rivers and not standing water, arrangement would be different. So it cannot be common for all over India. We'll have different standards.
Actually, no, that's not what I mean. No. Neha, what happens is even if there is a river, the backwater of river is not at the same flow. So we are looking at, see, I'm very clear, and I mentioned in my first introduction, is that we are looking at 5 to 10% of water bodies which are conducive to us. So we are not saying that rampant mein jahan jagah mile wahan pe floating solar dal do. No, that's not the place. The place needs to be studied, identified on ecology, environment, evacuation, and based on that, the projects have to be put out. So the answer is not a generic yes, but it is a selective yes.
I think we had those canal rooftop projects by the ministry.
Okay. Thank you so much. Thank you so much.
Yeah.
That is not floating.
That's not floating. Okay. So here there's another question from Mr. Rakesh Bhan. He says why the performance of floating solar is more than of ground mounted solar plant.
Okay. Typically what happens is the raw material for all these solar power plants is silicon, and there is a direct impact of temperature with silicon. That's the reason whenever you have a laptop, there's a fan which is there it takes the heat out. The same thing is that in a silicon, like I mentioned, there is for every 1 degree increase in temperature, there is a 0.4% in reduction in power generation. So that's the thesis, and this is the research. So now based on that, whenever we go into let's say Rajasthan, then the temperature goes up, the temperature goes to 50 degrees. So when the temperature goes to 50, there is a reduction in power generation. But the same, if it is done in a water body, because of the cooling effect of water, the temperature does not increase. As a result, the performance increases by 10%. This is the research by CD's research organization in Singapore. Have I addressed the question?
Yeah, I think Mr. Bhan, if you have anything else to ask.
Yeah, thank you very much. You have addressed the question. One more question related is that what is the benchmark project cost of this floating solar power plant nowadays, right now?
Very pointed question. Bhansa, what do you do, sir? I mean, if you introduce yourself, it will be better for so that I can.
Let me introduce myself to you. I am Rakesh Bhan. I am retired AGM and Technical Officer of State Bank of India. Throughout my career of 30 years in consultancy services cell of State Bank of India, I have worked for MSMEs, and moreover, I have studied ground-mounted solar power projects. I have also studied rooftop solar power projects. But before my retirement, I could not study floating solar power project because no project came for funding.
Okay.
So that's why I have asked you, being a finance person from finance, just to see if, whether the projects are viable or not.
See, typically, like I said, there is a 10% increase in the performance of the system, and there is a 10% increase on because of the project cost, mota-moti. Huh? So when you look at it, now I'm only looking at it from purely the point of environment. When we look at a utility scale, that's the reason I pointed out that 1400 square kilometers will be used for putting up a 60 gigawatt of plant. So these 1400, you and I both know that once you put a solar plant, the land gets locked for 25 years. When you look at a country like Israel, which is doing farming on virtually on sand, why are we locking 1400 square kilometers when the water is abundantly available? Why not pay premium?
Yes.
So that's where I'm saying. And anyways, we are stuck with food security and things like that. So why are we not using it? I have not touched upon a point which since we spoke about. In floating solar, there is also reduction in evaporation of water bodies, sir.
Yeah.
This is also a point that needs to be factored in. So it's environmentally and ecologically a fruitful thing to work on. That's what I would propose.
Okay.
So that's what I wanted to ask you about the hydrology of the partner. What is the water cycle? How the water cycle of a river water body is affected once you cover it? So
actually, we are only looking at 5% to 10% of water body that is getting covered.
Okay.
As a good practice. So we still have 90% water bodies available. So there is no direct impact on hydrology or bathymetry. So there is no direct impact. Okay. Only 10% will give us 288 gigawatt of power, ma'am. So I mean, it's a brilliant opportunity for us to explore, and those people who want to get into floating solar is the place to be.
Yeah. There's a question from Mr. Prem Bharti. He has asked that how the earthing point can be provided. So Prem, are you there? Yeah.
What is this? Can you just give me a background so that I can understand?
He is with us.
Yes, ma'am. Yes, ma'am.
Yes, please. Please, Prem.
Yes, ma'am. So basically, I'm asking, being the solar plant in the water body, the earthing point could be given right away from the source point, or is there any alternative method could be provided?
Actually, water is a bad conductor of electricity. Okay. So what happens is whenever there is any earthing point come in, we can actually put it up in depending upon the scale of the project. Let's say you're talking about maybe a megawatt scale project, then we can actually have an earthing on the ground. But when you're talking about an ultra high utility project, depending upon the location, we can actually ground it in the water body itself.
Okay, that's fine.
Because you need dead weights, that's about it. So once the dead weight is, and by the time the electricity starts getting into the water, it starts dissipating any which way. So,
but don't it corrode the especially rod, earthing rods and all that?
Actually not, because because of the water pressure which is there at the bottom, it does not have a serious impact on it. It does not corrode.
So I
Okay,
think
sir.
one, Mr. So this is Solar VKT. If you are there, you can ask your question and discuss, because he has talked about BAA standards for floaters. And
Am I audible?
are you there? Yeah, please.
Yeah.
Please.
Am I audible?
Yes,
Yes, you are.
Mr. Tiwari.
Yeah, very good afternoon to all. I am Vishal K. Tiwari. I am founder of Patanjali Solar and ex-chief executive officer. Now I am serving in Elcompanic as a general manager solar division. I found an opportunity to discuss this thing, the floating solar floater quality issue with the BIS standards. So I don't think there are standards available. Do you think so? It is available.
No, sir, not available. See, because each of them have a different technology. So when we talk about rotomolding, or when we talk about injection molding, when you talk about other technologies, the whole concern is that what are the HDP material that you're using, what are the binding agents that you're putting, how the UVs are interacting. There has to be a study, because then your product has to go through that rigorous technological assessment before the project has to be coming out.
Oh, that's great. The thing is that I have been also having a say into the solar marine navigation projects. That is a very niche area where we put solar marine navigation lights deep into the sea. That is also a solar floating kind of application. So just wondering if we all stakeholder can meet somewhere in near future, so that we can decide about standards and we can talk about all these parameters, standards,
Sure.
and we can make a suggestion, because I am also a part of Solar Association. I am also heading the core committee for business development in the association. So we have many people associated, especially related to solar and hybrid projects.
Sure.
So if it is possible that we all stakeholder can meet physically and discuss the thing for a day or for a half day, and we can suggest that we can decide the parameters, we can explore as much as we can, and we can sit across and we can decide it and suggest to the concerned authority, so that there should be a standardization into this, because I have seen many floaters are coming from scrap of China.
That's
Okay.
correct. That's correct.
Which is actually I have heard that. I have not definitely physically checked, but I have heard that that has been supplied to the Omkareshwar projects. Somehow I'm related to the Omkareshwar projects also. That I'll discuss it personally. But if it is so, then we are really polluting our water body.
That's correct.
Which can and this is going to be there for the next 25 years, which can be next level of pollution, which nobody can think of.
And microplastics will be disastrous, because it will get into your bloodstream.
You know how China plays in the developing countries market. You very well know.
Correct.
And that is why there are so many barriers made for the low cost, low quality material to be stopped at the entry level only. So if just wondering that if we can sit in the near future and we all can meet personally and we can
You shall
discuss.
be most welcome. We can actually meet. I'll just put my number in the box नीचे आपका डाल दिया है. We can happy to connect with you and we can take it up, sir. We can definitely take it up, because this is the
आपका
need for the hour.
या मैं और धमीजा मैम यहाँ पर हैं. मैं एक्चुअली
हाँ जी.
अनिल कुमार जी से मैं बहुत अच्छे से परिचित हूँ. वो मेरे बहुत अच्छे दोस्त हैं. हम लोग बहुत
हाँ जी.
शुरुआत से जब पतंजलि के समय से मैं उनसे बात करते आ रहा हूँ, और सिंह साहब भी हैं. तो मैं ये चाहता हूँ कि ये बहुत अच्छा प्लेटफॉर्म है जिसमें काफी अच्छे स्टेक होल्डर्स जुड़े हुए हैं.
हाँ
और
जी.
मैम आप तो मतलब बहुत शुरुआत से इन सब चीजों में जुड़े हुए हैं, और सिंह साहब भी हैं. तो मैं ये चाहता था कि हम सब लोग यहाँ मिलके एक दिल्ली में या कहीं पर हम ऐसे एक उसमें मिलके बात कर लें, सो दैट ये ये एक बहुत अच्छा इनिशिएटिव हो जाएगा सभी लोगों के लिए, और स्टैंडर्ड सेट हो जाएंगे रादर देन कि फ्लोटर्स वो कैसे भी आ रहे हैं, कहीं से भी आ रहे हैं। क्योंकि अभी मैं कुछ फ्लोटर्स मैन्युफैक्चरर्स को जानता हूँ जो हिंदुस्तान में बनाते हैं, वो बड़े सब स्टैंडर्ड रूप में बना रहे हैं, और चूंकि उनका कोई चेक नहीं है तो हमारी सारी वाटर बॉडीज जो है वो पॉल्यूट कर रहे हैं। और कहीं ना कहीं ये जिस दिन स्टैंडर्ड निकल के आएंगे तो फिर वो ये जो सेट इंस्टॉलेशन है इनको बदलने की बात आएगी। तो कहीं ना कहीं ये वो चीजें हैं कि अगर हम पहले ही इनिशिएटिव लें, मान लीजिए हम बहुत सारी चीजों में हिंदुस्तान बहुत आगे बढ़ रहा है, आज हम आजादी का अमृत महोत्सव मना रहे हैं, तो इसमें क्यों ना हम इनिशिएटिव लें कि भाई ये सेट स्टैंडर्ड्स होने चाहिए, ये इसके पैरामीटर्स होने चाहिए। इससे पहले कि कुछ आईईसी लेके आए, हम बीआईएस को क्यों नहीं सजेस्ट कर सकते कि भाई आप ये पैरामीटर्स डालिए, चाहे वो रोटो मोल्डिंग हो, आपका इंजेक्शन मोल्डिंग हो, या किसी और तरीके से बनाया गया हो। हम जो सोलर मरीन नेविगेशन के लिए बॉयज देते हैं, फ्लोटिंग बॉयज देते हैं, वो वर्जिन उसके बने होते हैं पॉलीमर के, और उसमें भी सेट स्टैंडर्ड्स हैं, क्योंकि ये इंटरनेशनल स्टैंडर्ड्स ऑलरेडी सेट हैं। तो अगर आप चाहें तो इन सब चीजों को लेके हम बैठ के काफी अच्छा बात कर सकते हैं, और इन सब चीजों को लेके बहुत अच्छा ये चीज डिस्कस कर सकते हैं, क्योंकि हिंदुस्तान में ना वाटर बॉडीज की कमी है, ना सोलर लगाने वालों की कमी है, और ना गवर्नमेंट की विल की कमी है। गवर्नमेंट की विल भी बहुत स्ट्रांग है। तो इतना अच्छा पेनिनसुला हमारा हिंदुस्तान देश है कि चारों तरफ हम, तीन तरफ हमारी वाटर बॉडीज हैं, तो इन सब चीजों को प्रॉपरली एक्सप्लोर कर सकते हैं और लोगों को पोल्यूशन से बचा सकते हैं।
ठीक है डॉक्टर सक्सेना, आपका कुछ?
Yeah, thank you so much, Sachin. It was really, you can see how well articulated your lecture was, that so many questions, so many discussions is going on. I have changed my hat from a normal MNRE officer to, or a NICE officer to skill council. So obviously my question would relate to that, as to how can we really develop a specific course which can be introduced in either in engineering colleges or environment colleges, so that floating solar becomes an integral part of our development. So in fact, this is not a question. In fact, it's a requirement from you that we would request your technical inputs to us, so that these couple of courses can be developed, and it is something which is going to come up in future. There is no doubt about it. There is a distinct advantage in floating solar, be it land or evaporation and so many other things, and obviously the cost would come down as we do more projects. So this is something which as MNRE we would like to propagate. And as far as developing of standards is concerned, VKT's question is, yes, we should, in fact, whenever there is a BIS standard made, industry is always consulted. And if we are looking at a large scale development in this area, probably we can take some initiative and make some standards. Finally, obviously, a committee has to be formed by BIS in consultation with MNRE to develop these standards. So with this, I think we are overshooting the time. Thank you, Sachin, and I would invite you to Skill Council whenever you are in Delhi, so that we can take it forward.
Certainly.
Formal thanks from Dr. Dhamija or PB Singh.
Yeah, I will just thank Mr. Sachin, and I will thank all the participants, and I would request Mr. PB Singh to give a formal vote of thanks. Yeah. Thank you. And
thank you.
Mr. Arpit, also you have joined. Any comments?
Yeah.
Hello. Good afternoon, Honorable Speaker. Good afternoon, everyone. So I was listening to your presentation and I was listening to your lecture. Floating solar is all the more very interesting area nowadays, because it is evolving, and there were a lot of insights which were shared by you. So I have personally taken some notes down, so that, whatever you have, the knowledge that you have given to us, maybe, when we are at a forum, so we can share this information to
Sure.
So I would really thank you, sir, for honoring us.
Interacting with us, and I would request. It was a very, very good lecture. I learned. I didn't know. I see. I confused canal top with floating. I know about OTEC, ocean thermal energy. There was a floating plant which I think so in National Institute of Oceanography had set up, but then it got vandalized in a storm, I think so. So we don't have anything in floating what we knew, but this I learned today. And I think I like to add on to my knowledge in this area.
Certainly.
And the BIS committee, you just approach Mr. Tiwari, you just write to them, they will constitute a committee. There is no, we've been on the BIS committee, on the solar committee, so many committees were there. So they will, because a separate committee needs to be constituted for standards for floating design.
Yeah, very true, ma'am. Very
Yeah.
true. And I really wish that we can meet in
Yeah.
near
I think
future.
Mr. Chandan is there. Chandan Banerjee, Chandan is there.
Can I have his number, ma'am?
Yeah, I can share his number.
Yeah,
No
please. You have my number on
I-
the screen, ma'am.
I don't know whether I have your number. I have Dr.
No,
Anil
no,
Kumar.
I have just shared my number here.
Okay.
It's on the chat.
Yeah. Okay.
the chat
Okay.
and,
I'll just pick it up and I'll give you his number. And he's been very cooperative and he's been very forthcoming in all these areas because these are all new areas. You know, BIS has to look for areas where new standards can come up.
Sure, ma'am. Sure, because it's really a serious issue on it.
Yeah. It is there. Ultimately, later on, we land up with problems, no? As you said.
True. Because these installations of non-standardized floaters, maybe maybe need to be removed in the near future if falling below the standards.
Yeah. So now I request Mr. P.B. Singh for a formal vote of thanks, and thanks, Mr. Rele. Yeah.
Yeah, thank you, ma'am. Thank you very much, sir, for the very knowledgeable and excellent presentation. The topic is very interesting and something different. And you, during the question answer, you replied very well. Thank you very much, sir. And before I'll say final thanks to you, I would like to thank my colleague, Mr. Girish Subramaniam, for introduce you. And thank you, Girishji. I would like to thank you, sir. I would like to thank all the participants for his valuable time and join the webinar. Thank you very much, all of you. Thank you, Satish Rele, sir. Thank you very much.
Yeah.
It was a
Thanks.
pleasure. Thank
Yeah.
you so much. It was
Thank you
really
very
a
much. Yeah. Have a good day.
Thank you so much, sir.
Take care.
Thank you.
Bye.
Bye, sir.